Hi, this is lesson 11.1.4, which we're finding the surface area of various three-dimensional shapes. We're going to kind of veer off course a little bit, and I'm just going to kind of give you the information today instead of working through the core problems. I just think that's going to be a little less clunky as we're working in this virtual realm. So let's start back where we were at the beginning when we started talking about prisms, just so you have everything in the same place. These are continuation of the notes that we did on Wednesday of last week. So basically for surface area, you want to find the area of all surfaces and then add those areas together. So in the case of this trapezoidal pyramid prism, we have the trapezoid on top, the matching trapezoid on bottom, and then we have 5 rectangles. Not 5, 4 rectangles as we go around the 1, 2, 3, 4 sides of our trapezoid. If you notice, this dimension of those rectangles would be the perimeter of your base shape, and this is going to be the height of your prism. So one way to find this, if you wanted to write a formula to find the total surface area, you would have 2 times the base area, depending on what that shape is. To that, you're going to add the perimeter of the shape times the height of the shape. That's going to get you those rectangles around the edges. So for this particular shape, we have our trapezoid. So our base area would be the top base plus the bottom base divided by 2 times the height of the trapezoid. And we want 2 of those. Plus the perimeter of the trapezoid would be 12 plus 5 plus 6 plus 5 would be 18 plus 10 is 28 times the height of 10. So then you can calculate those. We're multiplying by 2 and dividing by 2. So that part of that operation can reduce to a 1. So we get 18 times 4. Eighteen times 4 is 72, plus 28 times 10 is 280. So we get a total surface area of 352 centimeters squared. Okay, if we're talking about a cylinder, same basic idea applies. The total surface area would be 2 times the base area plus the perimeter times the height. Well, since it's a cylinder, that base area is always going to be the radius squared times pi, and the perimeter is going to be the circumference of the circle. So 2 times the radius times pi. So if we input that information in, we're going to get 2 times the radius squared times pi plus 2 times the radius times the height times pi. And that would be the total surface area of our cylinder. Now for pyramids, if it's a right pyramid, we can use this shortcut. If it's not a right pyramid, you're going to have to do a little bit more problem solving as you find the area of each different triangle that connects up to the top vertex. I drew a net of this pyramid just so you could kind of break it down and see what's happening. If it's a right pyramid, all 4 of those triangles are going to be congruent, so we can do this shortcut. If it's not a right pyramid, those 4 triangles will not be congruent, so you're going to have to do a little bit of problem solving along the way. Now, for our pyramids, we have the base area, plus we want to add in the area of those 4 triangles along the way. Well, all of the triangles have the same base, so we can take that perimeter times the height, and since they are triangles, we're going to divide that by 2. So you could have half the perimeter times the height if you wanted to add it that way. Okay, so in this case, my base area would be 6 times 6 is 36. The perimeter would be 4 times 6, which is 24. And our slant height is 12. That's an important piece of information, that this should be the slant height and not the height of the pyramid. So 36 plus 144 is 180 centimeters squared. I guess I didn't find the surface area for the cylinder, so if you want an example of how to find that, my radius is 5 inches and the height of the cylinder is 7. So we would have 2 times 5 squared pi plus 2 times 5 times 7 times pi. 2 times 5 squared would be 50 pi, plus 2 times 5 times 7 would be 70 pi. So we have 120 pi units squared. All right, the last shape that we looked at yesterday was a cone, or in the last lesson was a cone. So let's take a look at the surface area of the cone. So there's 2 parts to a cone. You've got your base area, and then you have what's called the lateral area, which would be the sides, that curved section. If you imagine this like a party hat or a snow cone wrapper, if you sliced that up and laid it flat, what you would end up with is a sector. And so what we're going to be doing is kind of working through how to find the area of that sector. That's really the hard part of this, because the base area is going to be the radius squared times pi, just like we expected it to be. But for that other part, really we want to find the area of the sector of that larger circle that we're working with, where the slant height becomes the radius of that larger circle. So the area of the larger circle would be pi times the slant height squared. And we want to find the area of the sector. So what we want to do is we want to compare that to the arc length of AB, which is 2 times pi times r. So this would be AB over the circumference of the larger circle, which would be 2 times pi times the slant height. So this would be the sector area, and this would be the circle's area. If we look on the left hand or the right hand side of that equation, both top and bottom are being both have 2 pi, so those can reduce. So we get the equation x over pi slant height squared equals the radius over the slant height. We're going to multiply both sides by pi s squared to get x by itself. So we get r pi s squared divided by s. One of those s's is going to reduce. So we get the slant height times the radius times pi is that lateral area. So this would be how you would find the surface area for a cone. So if we look at this, we want to take the base area, which is the slant height, which is the radius squared times pi. To that we want to add the lateral surface, which we said we could find by taking the slant height times the radius times pi. So if we were looking at this cone and we had a base of 10 units and a slant height of 15 units, we would take 10 squared times pi plus 15 times 10 times pi. So 100 pi plus 150 pi is 250 pi units squared. I would keep these notes next to you while you're working. That's going to be an important piece to help you work your way through this. You should be able to complete the independent practice and the formative assessment at this point. Thanks for your hard work. I appreciate you guys sticking with this. I know this is a different way to learn. Please reach out if I can do anything to help. Thanks.